Okay, today is Monday, October 2nd, and today we're doing Module 2, Lesson 3. Okay, and as you can see by your learning goal, today we're using pictures to model, write, and understand numerical expressions. What's another way to say numerical expressions? What does that mean? Go ahead and talk at your table groups. What's numerical expressions? Okay, I heard lots of tables say it, but I also heard lots of tables not talk to each other. So we have to work on our collaboration and our discussion. Remember, when you share your ideas with other people, it helps you learn. So if you just sit there and you don't say anything, you're not learning. The person doing the talking is the person doing the learning. So right now, because I'm talking, I'm the one doing the learning. And so when I want to share the learning with you, that's why I have you talk with each other. But if you don't talk with each other, then you won't learn very well, okay? But the people who I did hear learning and talking, they said that numerical expressions, another way to say that is number sentences. Okay, so when you think of addition sentences, multiplication and division sentences, those are all numerical expressions. Does that make sense? Yeah. Good. In your notebooks, I want you to make a little chart for yourself. And I want you to write down, or in your chart, there should be 4 columns. The first column should be addition. The second column is subtraction. The third column is multiplication. And the last column is division. And in each one, I want you to think, what English words could you see in word problems that would mean you need to add? Or what words might you see that might mean you need to subtract, or multiply, or divide? Okay, go ahead and see how many you can brainstorm silently by yourself. So once again, this is not a comprehensive list. There are more words than this that mean to add, subtract, multiply, and divide. But this gives you a good example. And throughout the year, your challenge is whenever you see a different one that's not on the chart yet, you're going to add it to your chart. Okay? Very good. Let's move on. The directions say to draw a model and then write the numerical expression. We know that numerical expression is another way of saying what? Number sentence. Very good. Go ahead and write these words down. 3 times the sum of 26 and 4. Copy it exactly as you see on the board. 3 times the sum of 26 and 4. Looking at the chart, we see some words that were on our chart, right? Times. What mathematical operation is that? Multiplication. What about when it says the sum? What is that? Addition. Okay, so we're finding 3 times the sum of 26 and 4. Now, what do we need? If we're finding the sum of 26 and 4, that means we need to add 26 plus 4. Now, I know in your head you're thinking, Miss O, that's 30. Can I just write 30? If I wrote 30, would it be writing this right here? No. Okay, so if it says the sum of 26 and 4, we're going to look at it like that. What does that look like in terms of a model? Because it says we need to draw a model. Well, I could have a bar here and show that this is 26 plus 4. I could even have part of it be 26 and part of it be 4. Does that make sense? Yeah. Now, what do we need to do? Is that our final answer, 26 plus 4? No, we have 3 copies of it, or 3 times of it. So what do we need to do? We need to have another 26 plus 4. And then over here, another 26 plus 4. Do you guys see how that's 3 copies of 26 plus 4? Right? So this is 3 times the sum of 36 plus 4, or 26 plus 4. Okay, how do I write that using a mathematical sentence? I can write 3 times the sum of 26 and 4. So right here, this is the numerical expression, the number sentence. This is the numerical expression. And this right here is the model. Does that make sense? Okay. Now, if we wanted to solve this, it would be 3 times what? What's the sum of 26 plus 4? 30. So it'd be 3 times 30. So the answer to solve it would be 90. So in fact, if you wanted to, you could write equals 90. Okay? Once again, I know in your head you're thinking, wait, I know this is just 30. Can I just write 3 times 30? No, because it does not reflect what it says up here in the words. Does that make sense? Okay, let's try another one. Let's start this time by drawing a model. So if I have the difference between 60 and 51, I can show that, right? The difference means what mathematical operation? Subtraction. So over here I have 60 minus 51, right? And if I'm tripling it, how many of those bars do I need to have? 3. So I do another one here, which is, and label it 60 minus 51. And then the third one here, which is 60 minus 51. Do you see how this model right here shows the difference of 60 and 51 tripled? Very good. How would we write that using a number sentence? Well, we could write 60 minus 51, and the parentheses are important because it would change the order of when we do things. And we're thinking, it shows that we're thinking of the difference of 60 and 51 as a unit, as one thing. And if we're going to triple it, Eva, what do we need to do? Multiplied by 3. Very good. So this is the number sentence, and this is the model. If we want to solve it, we could do 60 minus 51, which is 9 times 3, which is?
27.
Good. So the answer to this, if I had to solve it, would be 27. Can I write instead 9 times 3 as my number expression?
No.
No, because it is not reflecting what it says in the words. Does that make sense?
Yes.
Very good. This time, when we see the word sum, what do we know we're doing? Adding. If we have 2 12s, we're making 2 copies of 12s. So what are we doing to the 12s? Multiplying. And then if we have 4 3s, we're making 4 copies of the 3s. So what are we doing? Multiplying. Okay, let's draw the model first. Here I have 12. How many 12s do I need? 2. Very good. So let me draw 2 12s. Okay, then I have, here's a 3. How many 3s do I need? Huh?
4.
Okay, so let me draw 4 3s. 1, 2, 3, 4. If I'm adding all these things together, does that show that I have the sum of 2 12s and 4 3s? Very good. How can I write this down? I can write I have 2 12s, and I'm going to add that to 4 3s. Do you see that?
Yeah.
I have 2 copies of 12s, and then add it to 4 copies of 3s. Once again, this is the numerical expression, and this is the model. If I'm finding the difference, what am I doing?
Subtracting.
Okay. If I have 9 37s, what am I doing there?
Multiplying.
Just with this part. If I have 9 37s, what am I doing?
Multiplying.
I'm multiplying what 2 numbers? 9 and?
37.
Okay. And over here, if I have 8 37s, what am I doing? Okay. So if I want to draw my model, I can show here that I have how many different 37s at first?
9.
So I have 37, 37, dot, 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 all the way until I have 9 37s. So I can show that here there are 9 37s, right? Okay, in a separate bar down here, I can draw, again, that I have 37 and 37 and 37, dot, 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 dot. My last one's still a 37, but this time how many 37s do I have?
8.
8 37s, okay? So where is the difference? The difference is right here, right? Do you guys see this part right here? This is the difference. So I can draw a question mark here to show that that's what I'm trying to find. In the top bar, I have 9 37s. In the bottom bar, I only have 8 37s. So that red area is the difference between the two. Do you see that?
Yeah.
Okay. So if I'm trying to find the numerical expression now, if I want to write the numerical expression, if I have 9 37s, how can I show that using numbers? 9 times 37. Good. If I have 8 37s, how can I show that using numbers? 8 times 37. And if I'm trying to find the difference between these two quantities, it's important to put these two quantities in parentheses, even though you may not need to for order of operations, because it shows that we're thinking of those numbers as two quantities. Okay, so put those parentheses to be clear. If we're trying to find the difference between those two quantities, Young, what do we need to do? Very good. So that would be your numerical expression. Hey, what would the difference be, by the way? If I have 9 37s in the top and 8 37s in the bottom, what's the difference? How many 37s would be the difference, Stella? Sometimes we might see the opposite. We've been going from words to pictures and numbers, right? Sometimes you might see a number and then it tells you to write it in words and then to solve it. Okay? So what do we have here? First we have multiplication. What are some words we could use to make multiplication? Everyone? Times. So how many times do we have? 8. So we could say 8 times. But what are we finding 8 times of? What is this? I have a subtraction sentence. So what would the subtraction words be?
8 times the difference.
Very good. 8 times the difference between what?
43.
Good. 43 and 13. Here's what I do not want you to write. 8 times 43 minus 13. We wrote down minus because that's what a lot of people say. But minus actually has no meaning. When you're minusing, which isn't even a word, by the way, you're subtracting or you're finding the difference. So if you write on your paper 8 times 43 minus 13, that would be wrong because that's not showing me that you know that you're finding the difference between two numbers. Does that make sense? So I want you to go back to your chart right now. In your notebooks, I want you to make a little chart for yourself. And I want you to write down, or in your chart, there should be 4 columns. The first column should be addition. The second column is subtraction. The third column is multiplication. And the last column is division. And in each one, I want you to think, what English words could you see in word problems that would mean you need to add? Or what words might you see that might mean you need to subtract or multiply or divide? Okay, go ahead and see how many you can brainstorm silently by yourself. So once again, this is not a comprehensive list. There are more words than this that mean to add, subtract, multiply, and divide. But this gives you a good example. And throughout the year, your challenge is whenever you see a different one that's not on the chart yet, you're going to add it to your chart. Okay? Very good. Let's move on. Okay, so now that we're looking at our chart again, I want us to see which words have we used a lot. When we use sum for addition, difference for multiplication, copies for multiplication, and we could use quotient or half. Okay, those are the words we'll mostly use when we see numbers and we want to put them into words. So what I want you to do is I want you to take your highlighter. Please don't argue about what color you need. Just take a highlighter and highlight those words. Sometimes it might tell you to compare two expressions without calculating. This is the very important part. You're not actually solving the problems. And you might think to yourself, wait, Miss O, how can I solve or compare things without solving, without calculating? Let's take a look and see if we can logically think about this. Over here on the left side, we have 18 times 27, right? That's how many 27s do we have there? 18. Okay. Now over here on the right, we have 20 27s. And I'm going to take away 1 27. So how many 27s would I have altogether?
19.
So over here I have 19 27s. And over here I have 18 27s. So which side's bigger, the right side or the left side? So we can show that the left side is less than the right side. Do you see how, did we need to do any multiplication or any addition or any subtraction or any division?
No.
Not really, but do you see how you can just tell by understanding what those words mean? That the right side is bigger?